Hello, everyone. I think we can start off. Other people will join us and just find us along the way. Yeah, let me get a thumbs up. How are we doing today? Okay, hopefully we're all okay. Yeah, so today we'll be going through Flare Time Series Oracle, particularly building with Flare Time Series Oracle. And the implication of that is that we're going to be fetching price data using Flare Time Series Oracle, which is an enshrined data oracle in Flare. So what it is essentially is the oracle enshrined within the Flare protocol itself, and it provides high frequency data feeds. Uh, right now, it only provides that data for prices, external data for prices on different assets in different domains. It could be cryptocurrency asset prices. It could be prices of commodities and ETFs, and the list is extensible. So even yourself, you could suggest a new asset that could be added onto this list. And all this data is provided within the validation process, like we were talking about it earlier. All the enshrined protocols enable decentralized data provision. That means entirely through the core protocol of Flare itself as a blockchain. The validators themselves are also the attesters when you're working with FDC, are also the data providers when you're working with FTSO. So the data is provided in a decentralized form and allows for you to access it securely and use it within your smart contracts. So that enables you to have data that is accessed through a reliable system, but it's also provided efficiently, like we're going to see. So, what an oracle is essentially is a source of information. In plain English, it is simply a source of knowledge. So, in this case, an oracle as it is in terms of Flare, a time series or the Flare time series oracle, is that protocol that provides the price data for you on chain, so you can use it within your smart contracts and yeah, be able to build applications that are data rich and that are secure and resilient. But why is it important that an oracle actually be built within the protocol itself? Because the oracles that already exist and we can already query data from them and they effectively bring this data on chain. But why is it important that we can have an oracle that is built within the protocol itself? So, um, just to put it across, most of the applications that are built these days really need data, whether it's decentralized applications on chain or it is Web2 applications, they all do need data. And that means they need to have access to external information and be able to bring that data on chain, then utilize it for certain computations. But then when you think about it, it's easy for you to interact with data if the data is within perhaps on the blockchain where you actually deployed your smart contract and where your decentralized applications execute their logic. Because then you're sure of its security, you're sure of its integrity, because everything is verifiable on chain. But what happens if the data is being picked from an external source, whether it's a different blockchain or it's just from the internet, traditional internet data sources like Web2 APIs? How do you guarantee the security? How do you guarantee the integrity? How do you guarantee the reliability of this data? Because it's possible that you can actually provide the price data, the price data that you're going to use, perhaps if you want to know the price of Bitcoin or the price of FLR. There are so many Web2 APIs from which you can source this data, and it's easy for you to actually do this in the back end. If you're writing a decentralized application, all you have to do is put a signer in your back end, and you'll be able to access this data on chain. But it begs the question: what is the integrity of that data? If the Web2 API, for some reason, mm, didn't fetch the data correctly, what are the implications of those mistakes when they happen? For instance, if you are building a decentralized exchange and you're fetching this data through your back end and bringing it on chain, The risk is if you brought the wrong price amount for any asset, the implications are very serious because that would mean that a wrong amount of tokens would be taken out on the other end as an equivalent for the tokens that you put in if you have the wrong price. So to guarantee the security, the protocol that provides this data needs to be decentralized so that we can verify the authenticity of the data by involving more parties checking the origin of this data to see that we can actually provide this data in a decentralized format. So even traditional oracles as we use them in Web3, you cannot guarantee their security. You cannot guarantee the integrity of the data that they provide. And let me illustrate what could happen if an oracle is hacked or if a bridge is hacked in terms of the implications to what would happen in case of the data that is provided being price data. For instance, if um, if we were getting data from a traditional oracle and it was data perhaps for the price of FLR, currently FLR is approximately $0.015. So I checked this today and this is the standard, this is the relative price on the market right now for FLR. So if we wanted to do a swap, for instance, we want to do a swap between FLR and US OFT or USDT zero, the layer zero USDT equivalent. It's a stable coin, and for you to get an equivalent of $7.5, according to the current price of FLR right now, you'd need to offer 500 FLR, and that's the fair price. So you get approximately $7.5 of OFT, according to the price of FLR today. But what would happen if the oracle that is providing you the data regarding the price of FLR was hacked, and somehow the data that it's providing is no longer relative to this price of FLR, but changes so drastically that it goes to as high as $2? Because it's a matter of changing that value, and then the price is different. So your decentralized exchange is going to have a different price of FLR, and this is the implication. So now instead of you getting the approximate equivalent in real world value of OFT when you exchange FLR in that particular instance, if the oracle was hacked, now this is a traditional oracle that you cannot guarantee how it actually operates. It operates externally to the protocol on which your smart contract is deployed. If it was offering this data, inaccurate data, and was reading that the price of FLR is actually $2, of course we would all love for FLR to reach $2, but is that if that's what it reads on chain, but that's not the real world value of chain, then there's a potential of other tokens being stolen from whatever protocol that is using this as the accurate price of FLR. Because now, instead of it being $7.5 that you take out of the protocol, it could be a decentralized exchange, it could be a lending protocol. It shifts so drastically that it becomes approximately $1,000. So that means that for every $2 of FLR that you get, rather for every FLR that you take that you exchange, you get $2 equivalent of this stablecoin. So this would be a theft. This is actually a draining of a protocol. This is just as simple as it could be. It's not very simple to execute, but these are the implications of what could happen if an oracle is hacked. It's just a matter of presenting to you the wrong amount of the wrong pricing data, and this is what happens. You could lose billions and billions of money because now I gave an example of using 500 FLR. What if it was 5,000 FLR? In that case, that could be approximately 10,000 being lost from a decentralized exchange or a lending protocol or whatever it is, as long as it's a liquidity pool that is dependent on smart contract logic to issue certain tokens as equivalent for whatever has been put into it. This would be a very serious hack. And for this to be curbed, FTSO needed to be built within the core of the validation process, the entire software infrastructure of Flare, because then we can query this data from different sources and get the relative price. So in case one data source is hacked, or for instance, one data source is providing wrong information, we can always query this data from somewhere else. So there's a number of data sources that this data is picked from. You might already know some of these. This is Binance, I believe. So there's Coinbase here, there's Kraken here, there's KuCoin here. All these are different data sources from which these data providers get the data. So, for instance, if one of these data providers was providing inaccurate data, whatever they were doing that is not legitimate can be neutralized by the authenticity of the other data providers, the other data sources. So this is the advantage of having a decentralized data oracle, is that data can be fetched from different sources, and it's not just verified at a centralized point like traditional oracles are. You have a set of 100 data providers or a set of 100 validators that are going through the same process of fetching this data. So in case there's an issue with one data provider, the others can always neutralize the illegitimacy of one data provider and provide accurate data on chain. So the entire process is decentralized from from the point where the data is picked up to the point where the data is being utilized in your smart contracts on chain. Firstly, data is picked from several data sources. And that's already a component of decentralization, and it eliminates or alleviates the possibility of data manipulation or provision of inaccurate data. Then the second step, this is the FTSO workflow, by the way, so I'll talk about it after I try to explain how it's important that all this process is decentralized. Then the data providers themselves are also a number. It's not one data provider that is chosen, perhaps in a singular round to provide this data. It's a set of data providers that are delegated, by the way. I'll talk about it as well. A set of data providers that are providing this data for you on chain. So you have the assurance that this data is valid based on the fact that it was sourced from different sources, and it is also being validated. Rather, it's also being rounded off by a number of data providers. So at the end, you have a singular value, which is a median of all the different data prices, because there might be variations from all these different data sources. Why there is a variation is because for for data for data like price data, there is no standard of accuracy. There is only a relative resemblance in the prices, but not absolute accuracy. And this is achieved. Why these data sources are actually variant, and these specific data sources are the ones that I use, is because they build credibility of providing accurate information. So while one data source might be off the price of another by just a few basis points, when overall the price is relatively close to the same amount. But if a data provider provides data that deviates drastically away from what the others have, then the data they are providing is inaccurate. So whatever they have provided, when it's neutralized by the rest of the data that has been provided by other data sources, we can get a relatively accurate value. So moving forward, even these data providers are actually delegated. What that means is that for them to even participate in the process of bringing FTSO data on chain, there have to be users in the background that delegate their FLR tokens, which is the native currency. Of course, it's wrapped first before it's used for delegation, that offer their delegation to these different data providers. It's kind of like giving them, let me say, power to do this job of data provision. So the more a person has in delegation, the more likely they are going to be trusted. during the rather trust not just trusted but also chosen during every round of data provision for FTSO data. So how it works actually is that when these data providers are chosen, not all of them are chosen in a single round. For instance, if I wanted to find out the price of BTC or FLR, this data will always be on chain because the FTSO protocol works throughout. It doesn't only work on request. So it provides the data for you. Rather, it provides the data on chain, and all you have to do is query it whenever you need it and use it in your smart contracts. So it's provided on every block creation. A new process of data provision is initiated. And this is what happens. The people that are chosen to provide the data, for instance, if I'm talking about the price of Flare in a specific instance of a block that has been created, not all the 100 data providers are chosen, only a set of them is chosen. But how they are chosen is random using a certain function called a VRF. If you've used data oracles before, you must know what a verifiable random function is. It's just a function that generates random values. But these random values are verifiable in the sense that, for instance, if someone was trying to, if you used it in a game, for instance, we might actually use it in one of the sessions ahead. If you used it in a game, for instance, the randomness cannot be manipulated by anyone and can be verified that this is actually the number that was generated in this round of generating a random value. So each of these validators is chosen by the verifiable random function, basing on their weight as well. So this data is called block latency data, or they're called block latency feeds because every time a new block is being created, this data is provided and updated. So if the price of FLR shifted by a few basis points within an amount of 2 seconds, by the time the next block is created, you would have the new accurate price of FLR. And this is how it works. On every instance of blocks are created at a frequency of about 2 seconds on the Flare blockchain. So every time a block is being created, the verifiable random function is executed and it selects which data providers are going to be chosen for that round, pick that data and provide it on chain. Price data. It can be the price of anything. You just have to query it, and we'll see some of the assets that are accessible to us through FTSO, the prices that we can actually query. So then after this data has been provided on chain, you just have to use the FTSO endpoint smart contract on the blockchain or the Flyer blockchain to access it and then use it in your smart contracts. So later on, we shall look at commit reveal and anchor feeds. These are more into FDC, but yeah, so this is the workflow for FTSO. It might be a little bit technical, but as we move on, we shall understand it even more. So are there any questions so far about FTSO? If I need to clarify something about it, I could do that now. Yes, Vianney.
So if I want to be among the nodes that are providing this data, is it something that is centralized to a few participants, or there is a way I can contribute to making this data available on chain?
Yes, you can actually participate to be a data provider. Just give me a moment. I want to share something in that regard. Maybe let me share my entire screen. So I think we'll have a session where we just talk about node running, for instance. But just trying to. There's a site I wanted to show, but I think I'll show it later on. It's okay. So it's possible for you to be a data provider. Just a set of requirements you have to achieve and you need to achieve some delegation for you to be able to be an effective data provider because there are rewards that are offered. And of course, as a person that is having a machine running online almost 24/7, it's necessary that you get rewarded for it to be able to maintain the infrastructure. But that for you to have the possibility of providing that data and get rewards, you need to have stake from people that are holding FLR. And yeah, maybe we'll have a session and talk about it. But yeah, it's possible for you to be a data provider. Okay, so yeah, we've been talking about FTSO being an enshrined data oracle for price data. And by virtue of the fact that it's actually enshrined, guarantees its security. Because the security guarantees of the Flare blockchain itself, it inherits these guarantees, these security safeguards, because it becomes even much harder to attack. So for one oracle to be secure, it's much easier for it to be attacked, first of all, if it is centralized. The more decentralized an oracle is, the harder it is to attack. And on top of that, Flare added that this oracle is actually into the protocol itself, because that means attacking the FTSO data oracle, you need to attack the entire blockchain, which is computationally expensive and prohibitively impossible. So it's secure by matter of fact that it's built within the protocol itself. And then it's fast because all the price data that it provides is available to you every 1.8 seconds in an accurate and updated format. Then it's scalable. What that means is that beyond the assets that are available for you to use right now, rather for you to access right now and using your smart contracts, you can actually add request for more assets to be added on chain. So I can actually think I saw somewhere here where you could actually make a request through the GitHub repo, rather through the GitHub account on Flare for new data feeds to be added on the FTSO, make them more accessible. But even then, you can still get price data, even if it's not within FTSO, through another data oracle like that we'll talk about. But I'll also offer a little bit more detail later about how that is possible. I saw somewhere where you can actually request for other data feeds to be added. For instance, if you have a new token and you think it's necessary that it's included in FTSO data provision, perhaps you want to maybe make it available on Spark DEX, the most prominent DEX on Flare. Yeah, right here. So you can request a new feed if you're interested in having more data feeds added to the FTSO protocol. So yeah, that's now possible. That's why it's scalable. It's not only going to be that what exists now is all that there's going to be. More data feeds are going to be added more and more. So yeah, and it's manipulation resistant because of the things that we've talked about, being that it's enshrined in the protocol itself. And then it's cost effective because this data is actually provided for free. For as long as you're using it as a developer on the front end, it's provided for free. All the data feeds that are provided through FTSO are free, exclusively free. And that makes it cost effective. And these are the benefits of FTSO over other oracles. And I think we can just get into the code and see how we can actually utilize FTSO. Just a moment. So beyond us just providing this data on chain, I want us to do something practical. So I would have loved to use an off-chain IDE because it gives me more control, but yeah, I think Remix is more convenient for all of us at whatever different levels of expertise you might have. If you've been building with Solidity, you should be able to use Remix. Uh, Up to this point, is there anyone that that doesn't have experience with Solidity, or perhaps requires some sessions to be able to understand some of the things that we'll be doing. If someone is in session and you'd love sessions about Solidity from the very start, you could just raise your hand, or so we can catch up later and see where I can, get resources for you. Okay. So moving forward, I want us to build something with FTSO. Let me just call this document. Okay, just creating a new document, and from here we should be able to build with FTSO. So all the information you need for you to be able to work with Flare is in the Flare Dev Hub. I'll share the link here if someone wants to build along with me. So if you've been, if you've deployed smart contracts before, you know you need a number of things. You need an RPC to import your network, the network that you're going to be deploying on in your wallet, so that you're able to sign the transactions on the correct network. Okay, so I'll just write a simple smart contract and see how we can actually fetch this data, FTSO data. I'm going to call this FTSO, and then see what I can write here. So yes, now for you to interact with FTSO, you need two very important contracts. One is actually an interface, but the other is an actual contract. Uh, One is the contract registry. So this actually has all the contracts that you need to interact with the protocols, the different protocols, including FTSO. There are different contracts that give you access to these ensuring data oracles, ensuring data protocols. Contract registry, and I will show you where to actually get them. Contract registry, then you need, for instance, now we're going to be building on the network, on the test network, Flare test network. So the interface that we are supposed to get is also called the test FTSO protocol. It's called, let me actually pick this information from here. So we'll configure these networks in the wallets, but I want us to write a smart contract first so that it's easier for us to come back to this when we have something concrete. Okay, everything is documented here in this sample smart contract. So you can just come and copy it, but I'm going to redo it so that it's easier for us to understand what I'm doing. So I need the contract registry and then the test FTSO V2 interface. I hope we all know what an interface is in terms of with regards to Solidity. So these are the locations at which you can find all this information, all these specific contracts. And this actually links to the NPM registry, the Flare NPM registry. So you can always find all these contracts there. I'm just going to copy this, but if you want, you can actually look it up on the registry, NPM registry. So when you put this here like this, when you import it from that location, or when you put that as a location you want to import this contract from, in this case, this one is a contract registry. It will crawl to the NPM registry where this information is, and bring the contract itself. So the same thing given for the interface, for the test FTSO V2 interface. So this is the second version of FTSO that we're going to be using. That's why it's called V2. And yeah, I need this one. So you can always come to this test smart contracts and get these links. And yeah, you'll be able to access both the contract registry and the test FTSO V2 interface. Okay, I'll hide that for now. So the first thing we need to do now is get the actual instance of FTSO contract that we can use to access FTSO, the FTSO protocol, and we can find that on the contract registry. So how I can do that is, first of all, the result that I return should be of type test FTSO V2 interface, and I can choose for it to be internal because I don't need it anywhere else. I'm going to call it FTSO instance. If you've used an interface before, this should be familiar. So, but I'm going to get it from the contract registry. Okay, so from the contract registry, I call a specific method to help me get that instance. And the method is called get test FTSO v2. So with this now I have an instance the of the smart contract that gives me access to FTSO as a protocol. And then the second thing I need to have is uh, is the feed ID of the specific asset I want to get the price of. So the feed IDs are actually also here. So when you come to FTSO get started, on the sidebar we can see block latency feeds. From here we can get all the feeds of the different assets that we could query through FTSO, the feed IDs rather. So you copy this and perhaps paste it here if you would love to take a look. I think I will share some of these links in the forum, but if I forget, please remind me and I'll share the links that we're looking at today. So you can get the block latency feeds here. So specifically, when I scroll down, I can see the price feeds of different assets. So we have FLR USD, we have Songbird USD. So Songbird is also a Flare network. We shall look at it slightly later. It's a canary network for Flare. And we have all these different assets that are accessible to us through FTSO, ETHUSD, but specifically the one that I want is FLR USD. So it's the one that I'm going to pick. And you can see there's quite a number of them. So I'll take this FLR USD. These are bytes 21 feed IDs, and they're encrypted in a specific pattern that I won't really go through right now. But if you're interested, I could maybe write a small article about it, or perhaps have a record a video about it and why they're recorded this way. So each of these specific feed IDs has a number of components that describe the specific assets that they represent. The category, then the feed name, and then of course the padding for it to continue to be a complete 21 bytes um, feed ID. So I'll copy this and yeah, then declare it here as a variable, actually as a constant because it's not going to change. And it's important for you to declare certain parameters, certain attributes as constant because it's gas efficient, and in case you know something isn't going to change, it's always best that you just declare it as constant. So I want this to also be internal. I'm going to call it FLR USD price feed. I paste that right there. So when I put this into the FTSO instance, calling specific methods on this instance, I should be able to get the current price of FLR. which is the Flare native token. So as you might all know, all operations, all computations in a Solidity contract happen within a function. So I'm going to call this function get price and pass in this information. So I'm trying to run fast because I want us to build something practical with it. I'm going to make this external, and allow it to return the price given to 256. So currencies and monetary value in Solidity smart contracts are represented as 256 bytes integers. And yeah, so here now I can access the price. What I have to do is call a specific method on this instance and then pass in this feed ID. Then I'll be able to get the price. So let me just pass in the different return values. So that method I want to call is specifically, let me just call it right here, FTS for instance. There's a number of methods you can use to actually get the price of a specific asset. So FTSO instance. This one, get feed by ID, is the one I'll start with. Then I'll use another that gives us relatively different results, return values rather, but does return the price. So then I pass in this feed ID right here. And I should be able now to get the price of FLR when I deploy this contract on the correct chain. So this method returns a tuple. Let me put the values here. So the first value is a U*256, which represents the price itself. The second is an int8, represents the decimals that this return value has. Then the third is a uint64, which represents the timestamp in which this data was derived on chain, was brought on chain. And this is helpful for you as a developer because it allows you to know the accuracy of the data that you're fetching. If you've been in DeFi for a while, you know that this is really, really important because sometimes it can make the difference between a profit and a loss on a specific trade that is happening, for instance, on maybe a decentralized exchange. Computations go on so fast in these kinds of protocols that for you to have the accurate data in every second is very important. So it's important to also know the timestamp in which this data was delivered in relation to what the time might be right now. So that's why this is important as a return value. Okay, so then here I just declare the variables that I want this tuple to destructure into. So this first one will be a price. The second will be the decimals. Or maybe let me just return it from right here so that we can see all these values in. Yes, let me just return it and then deploy these contracts. So with this, we should already be able to get the price, the decimals, and the timestamp during which this time was brought in. So yes, now for you to deploy smart contracts on Remix, of course, you need to give Remix access to your wallet, specifically the browser wallet. And I'm just making sure it's actually active to see that I actually have some tokens. Yeah, I have 66 C2FLR tokens, which are the testnet tokens for Flare. And I can use them to deploy. So when I go back to this documentation, there's a section where I'm able to see everything that I need, including the faucet where I can get tokens for testing my smart contracts. So when you come to the developer hub, in the home of the developer hub, you can find every information here. You can import your Flare network, the testnet and the mainnet from here. All the information is here, the configuration. You can import the Explorer, and then for the testnet, the link to the faucet is right here. So the faucet drips 100 FLR tokens, C2 FLR tokens, which is more than enough for you to deploy several smart contracts. So you can always come here and see all this information. Okay, I could share that. I think I shared it earlier even, but it's okay. So now I want to connect my wallet. I will connect MetaMask, I believe. Yep. Takes a little while, but you should be able to connect. Okay, I think it was actually already connected. All right, so yeah, you can see the balance that I have here. So when I'm done with that, I can deploy. So Remix added a feature for verifying contracts after it deploys them, but it doesn't work for all chains. So sometimes after you deploy, you might see a little error down here. Like it failed to verify, but that is still okay. Your smart contract will be active. You can actually verify it on for Flare. You can really verify them on the Block Explorer itself. Okay, so I click deploy. Should be able to have these smart contracts deployed in a matter of seconds. Okay, so we just need to wait on for a short while as the contract deploys. Meanwhile, if there are any questions, you can ask them. Yeah, give it a moment. So when using FTSO, oh wow, it's already deployed. Okay, now I can access my smart contracts here. Okay, as you can see, this actually failed to verify the contracts. And yeah, I think this smart contract can really be a view function because I'm not running any transactions really. I'm simply getting, excuse me, I'm simply reading a value from FTSO, the FTSO protocol. So I'll deploy it again as a view function so that you shouldn't spend any gas trying to fetch this data. So it's important for you to, especially if you're having functions that are not exactly modifying the state, to annotate them as view or pure functions, because then they would not prompt you to sign any transactions in your wallet. They would simply pick the value from on chain and then deliver it to you off chain. It might be on interfaces like this, like Remix, or it could be on the front end of your decentralized application. Okay, let's give it a moment. Should be able to deploy. And from here, then we'll be able to get the price of Flare and building something something really small with it. And you can make suggestions of what we can build with it, something that can take us about maybe 10-15 minutes. So yes, that's failed to verify, but that's okay. The contract is already deployed and I can see the function right here, get price. Now when I click get price, yeah, it should be able to show me the values down here. Oh, this is exactly what I was trying to avoid, but let's do it anyway. I think I used the old contracts, first one I deployed. Okay, but this was really unnecessary because I'm simply reading a value from a protocol on chain. I'm not modifying any state, so it should have been okay for me to just view without having to go back and sign and spend some of my tokens signing a transaction. But yeah, it's okay. Should be able to show me the value, but maybe I need to deploy it again. No, I think I used the old one. Let me see what's the issue. Okay. The contract seems to be okay. Nothing is wrong with it. Customer returns. I don't know why it's showing this. Let me first refresh it. Perhaps it will work. So as my remix refreshes, could be showing you a few more things regarding FTSO. So yeah, you can always come here and find the information you can test with, and also um, build on the main network. All the information is here, but you can also reach out in the forum in case you have any questions, and yeah, we'll be able to resolve them. Okay, so these are all the price feeds as price feed IDs as we've talked about them, and they're basically the same both for testnet and mainnet. So you don't have to worry about trying to fetch data with different IDs. And there's also guides here just in case you need to build specific things. There are starter kits here that you can work with. And even if you haven't built written smart contracts before, later on we'll go through JavaScript SDK and Rust SDK for you to access FTSO and all the other Flare protocols to be able to build something for yourself on the front end. It's not exclusive to only smart contracts engineers. Just the beauty with Flare is that it made it accessible for almost anyone with any developer background to access these protocols from the comfort of their experience, whether it's with building front end or back end interfaces, you can access these protocols. Okay, let's give it a moment. So I've been thinking of um, building a simple staking platform that has some kind of threshold. Like for instance, a person can only put in an equivalent, rather a minimum amount of perhaps maybe $2. And if you try to put anything below that, no matter what the price of FLR is, it will always require that you put in that minimum amount. I think we can do that in a short time. I don't know why it's not showing my contract. Should be able to show it. Let's give it a moment. Oh, wow. Ah, mix. Hopefully I need to refresh it again. So yeah, I think we should be able to finish in about 15 minutes. And yeah, if you're already thinking about what you could build with FTS, or you can hit me up in the forum if you um, bump into any issues. I'll be willing to help. Okay, yeah. So the smart contract is here, and it should be okay. It's really okay. Still compiling, but I think I can already connect my wallet. All right. I think the wallet is connected. Just a little bit slow, but yeah, right there. Still compiling. Wow. Okay, it's done. Let me redeploy this contract. So when we can see the price, then we'll be able to make the manipulations after we're sure of the specific things about this price, in terms, especially the number of decimals that it has. Because with Solidity and generally dealing with data that requires accuracy, things like funds, there are differences in terms of the decimals that are provided for you on chain. For instance, for Bitcoin, the decimals might be different from the ones that are provided for FLR, for Ethereum, and some ERC20s. Actually, most ERC20s have a completely different number of decimals from these other tokens, and it's a very elusive concept, but very interesting when you actually grasp it. You can always know how to navigate around. Okay, so yeah, I have this function, and when I call it, it should get me the price of, was it FLR I requested? Oh, it's kind of dropped 1.44. I checked a few minutes ago and it was at least 1.5, or rather 0.015. Yeah, it's still approximately 0.015. From here you can see that's the price, the trading average for today. But the closest value to right now is that price, as you can see it here on the front end. That's the price that's the price of the FLR for the most recent round of data provision for price data, and it has 7 decimals. So this is where things get very interesting. So now what I want to do is, now that I'm aware how many number of decimals it has, I can now do certain things with this value. So what I want to do is just limit a specific amount to, let me actually change this name and call this function, rather this contract, uh, staking. So I want to enable a platform where someone can bring money into the contract, but there's a minimum that is required for them to stake. So I'm going to call it staking. And I'll be explaining some of the things that I'll be doing. So instead of me getting the entire tuple, I want to now just pick the actual price. It's the one that I want to return. So it's the one that I will define here as I'm getting the price. Okay. So the first value is supposed to be a U into 56, which represents the price. Then to ignore other values that are returned by a function, if it returns a tuple, you simply put commas. So the comma represents the value on the other side being ignored. Then the second comma also represents the value after it, excuse me, the value after it also being ignored. So this should allow me to get the price. I'll simply type here price. But the issue with this price is that it has 7 decimals. So let me explain something here. So when we're sending tokens to a contract, they come in the form of way. I'm sure we If you've been building, you know this. So uh, in the form of way. So a single ether in values of way has 18 decimals. Let me just say one ether, and I will explain why I'm actually talking about ether as well. Is an equivalent of 1 to power E18 in way. It's a very large value when you bring it on chain. So maybe if you are sending 0.1 ETH to the contract, it would be 1 exponent 17. So it just reduces the decimals by the value of zeros that are after the significant value. And we'll see how this is written actually. If you've written smart contracts, I'm sure you're familiar with this concept. So smart contracts, particularly in Solidity and many other languages, don't deal with decimals. So that is covered up for the decimals are used are replaced with very large values to enable some kind of accuracy. So now the issue I'm having right now is that when I put values, when I send funds, FLR tokens to my contract, they are going to come in the form of way. So if I sent one FLR token, it would be an equivalent of 18. That would be one FLR. So why I was talking about ETH is because Flare is EVM compatible. What that means, it runs um, on a similar software infrastructure. The core that runs Flare is similar to the one of Ethereum. So one of the things that was implemented with EVM is that the values that represents funds are represented by 1 to power 18, 1 to power E18 for a single unit of a native currency. So a native currency could be one Ether, could be ETH for Ethereum, or it could be FLR for Flare. So even on the front end, when I send funds to my contract, when I send funds to this contract, I don't know why it's showing that. Um, Here it will show ETH because Remix was designed essentially for Ethereum. But in the background, since since I've deployed on Flare Coston 2, it is actually going to be FLR, not ETH as it reads here on the front end. But the concept is the same. So that means you don't even have to change anything. If you have built a smart contract for Ethereum, it works just perfectly for Flare. For as long as you haven't touched any of these core components, it will do exactly the same thing. Where there was ETH on Ethereum, you will have FLR on Flare. So it's exactly the same thing. But you just need to understand that concept that they're represented with the same denomination. A single unit of a native currency is equivalent to one E18 on a blockchain. So the minimum value, rather the smallest unit of a native currency is called a way in EVM standards. For other non-EVM standards, it's really having different names and has a different number of decimals. So now the issue I have is that when I send money, if I send maybe one FLR, it's going to be equivalent to one E18. But in the real world, one FLR, the value of one FLR is some significant values, but it has only 7 decimals. So you see there's a distinction between these two. Now what I have to do is regularize the value that I get from the real world, from the Oracle, which has 7 decimals, for them to be in the same standard. So that means I either give it 18 decimals or I take the value of ETH, rather the value of FLR, and reduce it to 7 decimals as well. But for matters of accuracy, it's always easier if you have more decimals. So I'll just pick this value and convert it into a value that has 18 decimals, because then I can move closer to accuracy than further away from it. So that's what we're going to do in the contract. And for instance, let me just do a simple mathematical demonstration so that we understand what is happening. So one FLR is an equivalent of a certain value that we got that has 7 decimals. How about if I have 0. If I send 0.2 FLR, how do I get the accurate price? In standard math, I would take this value 0.2 and then divide it by maybe the price of FLR, but we already know these, so we just want to find out the price in that denomination. So this is 0.2, okay, and this would be 1E18 because that's the actual price of FLR. So I want to find out the price in maybe dollars. So 0.2 FLR will be represented in the same quotation. So this would actually be 2 exponent 17. We'll actually write it down. Then I would multiply this by the price over a unit of FLR in the real world by the value. So typically in math, you would carry out this computation first and then multiply the result with the value. But the issue with this computation in terms of solidity is that it's always going to result in a value that is less than 0. Rather, that is less than 1. So it's always going to be 0 point something. And solidity does not deal with decimals. So that means that this will always resolve to a net 0. That's not helpful for our computation. So a workaround for this kind of issue is that you always do the multiplication first and then the divisions come second. When the division won't have the impacts of resulting into a 0, because this value would always be large enough to bring you the accurate value without having to go to a 0. So that's exactly what we do. Now, the first thing I'm going to do, because we know this value has 7 decimals. So for me to regularize it into an 18 decimal value, how many decimals am I left with to make 18? So this is 7. If I had 8, I'm left with 11 decimals. Yes, I think. So I would multiply this by 10, which would be the base of the exponent. So this would be, now this has 18 decimals from here. So yeah, I have the price. I don't know why it's showing an error. It should be able to work. Expected primary expression. This would be okay. Okay, now I want to get the price, get the conversion rate of the amount that I'm going to send to the contract. Get the conversion rate in terms of dollars. So I want this also to be internal and return for me a euro into 56, which would definitely be the price of the amount that I'm going to enter, that I'm going to send to the contract. So in this case, I would just put it here as a parameter and say sent amount, for instance. This is a U in 256. Okay, I think Remix is quite slow at resolving errors, but it would be fine. So what I do here instead, so typically I would, like the computation we've been talking about is exactly what I'm going to do. So now our price is it has 18 decimals. So let me just bring it in here, unit 56. I'll just call this method because everything that I need to generate the price is really within the method itself. It's external. It needs to be internal. Its visibility needs to be available. It needs to make it available within the contract. Okay, it returns a value, get the price. Just call this current price perhaps. Current price. Yeah, I need to return for us the value. The price of FLR of flare in adjusted to have 18 decimals. Okay, so we have that. That's the price. Now what we're going to do is simply multiply this current price by the amount we've entered because this would be in way, so it would have 18 decimals. if it was a single unit. If it was less, it would have 17 decimals, but that is the denomination that we're using. We've regularized the current price from the front, rather from the protocol to have 18 decimals. So it's really the same thing we're working with the same standard. This is current price. Multiply this by the cent amount. It's just something simple and practical to show, just to demonstrate how this data can be used. No matter what changes, it will always deliver this kind of value, like we're going to define it. So then I'll divide this by 1E18. Then that is going to be the conversion rate in dollars of the price that I'm going to enter, of the amount that I'm going to send to the token, rather to the contract. Okay. Now here goes the function for deposit, perhaps. Deposit. So first of all, for it to work, I just want it to be external because I don't think I will need it. I'll need to call it here. It needs to be payable. This is what allows a function to actually accept funds. So what I would say is if get conversion rate, so I'm going to call get conversion rate on msg.value, which will be the price, the amount of tokens that I brought into the contract. So this returns the price in dollars. So I'll just call this method on this value. So I'd say if the price in dollars of what I have entered is less than a certain amount. So now, for instance, I want it to be maybe 0.2. I don't have a lot of FLR tokens, so I'm going to put a low value. Maybe I need to have 20 cents. So if a single FLR token, this is just be basic math, but it can get a little bit confusing, but let me put it here. So if one FLR token is 1E18, that means 0.2, which would be 20 cents, is 2E17. You just reduce it by 1 0 to cover up for the decimal, that's the movement of this decimal value. So that's what I will do here. So if that value that I've entered is less than 2E18, which would be an equivalent of 20 cents in the denomination that I have used, then what should happen? If it is less, then maybe I should revert with an error and tell the user what you have sent is not enough. Yeah, so I could actually put the value here as well. And also I need to define this error. I'll just put it out here. Error. Say it's not enough. Then inside here, because I passed a value of urine 256 type, if we had time, I'll show you how to really make it more efficient. But in the interest of time, I'll just yeah, I think this is it. This is the function. So what would 20 cents actually be in dollars in terms of tokens? We'll find out as we try to send more funds. As we try to send funds, try out different prices and see what happens. So I'm going to deploy this contract again and see what it does. Okay. 20 cents should be, because it's 1.4, should be approximately 10 FLR tokens, perhaps. Yeah, probably. But we'll try it out and see. So when I confirm and deploy this, it should be able to okay. Yeah, should be done in the next few minutes. Just wanted to demonstrate how we could actually use this data So this is just one of the simplest ways, just a simple example of how you can use this data. And no matter how it changes, it will always give you the accurate result. So it's one of the same principles that is used to calculate gas for every transaction depending on network activity. So yes, I am going to be sending FLR tokens. Now, instead of sending Wei, I'll be sending Ether. So like I was saying earlier, Ether simply represents the native currency. In this regard, it doesn't refer to Ether, the native currency of Ethereum. It's simply a representation of a native currency of an EVM compatible chain. So in this case, since I've deployed on Flare Custom 2, this represents C2FLR because that's the native currency on Flare testnet, Flare Custom 2 testnet. So I'm going to attempt to send three FLR tokens, C2FLR tokens, and then attempt to deposit, see what happens. So it warns me that there's an error. And this error will be very confusing sometimes because it always reads gas estimation error. What happens with a smart contract is that when you're calling a function that is going to run a transaction on chain, it first calls the method estimate gas. So it kind of simulates the transaction to see how much gas it would require for you to deploy the contracts. And then this error can, yes, be accurate, that you actually don't have enough gas. But also if it runs into an error when it's trying to simulate the transaction, it will always bring the same error. But sometimes it could really be because it has maybe hit a revert statement. Like in this case, there's a revert statement here. So if it hits this statement, it will always show you that there's a gas estimation error. But really, you should be very cautious to be able to troubleshoot these issues. So I sent 3 FLR and it didn't work. Let's see what happens if I send 15 perhaps. Do I have 15? I have 66 here.
But if I change it to about 17, because that's just over 20 cents, and I deposit, it should allow me to actually make the deposit. Yes, so this actually succeeded, and we should be able to see about 17 FLR, rather 18 FLR here in a matter of seconds. And here it goes, 18 FLR. So this is exactly how you could use this data, and it will always depend on the current price of FLR.